Hello, my name is Douglas Napoleone. I'm here representing Nuance Communications, Inc., a local Burlington company, and the Python Software Foundation. I have the privilege and honor of introducing Ivan Krstic from the One Laptop Per Child project, along with Eben Eliason. Mispronounced that, I apologize. And if you're not familiar with One Laptop Per Child, it is a revolutionary project trying to bring education to the children of the world. Without further waiting, here's Ivan.
Hi, thanks. So you'll need to give me about 30 seconds to get set up. Okay. All right, so very glad to be here. I'm going to, I decided to do something different with the format of this talk from what I normally do. I'll certainly explain to you what's OLPC, what I do for OLPC, and what we're trying to do. But I'm going to try and keep the actual talk and the slide deck relatively short. When I'm done, I'm happy to take questions. I'm going to talk about sort of the core technologies and sort of the core idea behind the project. And then I brought a colleague that Doug also introduced, Eben Eliason, who is in the back, who's going to come up and then show you what we're actually doing on the user interface side and demo an actual laptop for you. So I'll dive in. This is our sort of very brief agenda of things to run through. This is a URL that, if you're interested, you should write down. Because I'm cutting sort of this, the actual slide part of this talk very short, there is a very detailed technical talk that I gave at Google just a few months ago. It's pretty much completely up to date, and it goes into it's about an hour long, and it goes really into complete detail about all the technology stuff that we're doing. And I'm going to be leaving a lot of that out today as I try to instead get through things quickly and then sort of open up the floor to you for questions. I do like being interactive in talks, so please feel free to interrupt and ask questions at really any time. So who am I? Why am I talking to you? I run security for OLPC. I do a lot of other system-related things. What I don't do is almost anything that the user sees, which is why I actually brought Eben with me. And OLPC came to me sometime in the middle of last year. And it was sort of an interesting conversation. They asked me a couple of questions when I first talked to an OLPC person. And the questions were, can you secure 100 million machines? Can you rewrite the file system? And by the way, can you make this usable by 6-year-olds? And as far as interesting job interviews go, this was quite a trip. The thing was that I'd seen OLPC in the news. I'd read about it in the papers. I didn't know that much about what it is that they were actually trying to do. And I set out and tried to sort of figure this out on my own. And I found something interesting, which is that the goal of the organization, the goal of One Laptop Per Child, doesn't involve the word laptop anywhere, right? So the goal is very simple. It's 4 words: change how kids learn. Laptops are really not in the picture. And how does this work, right? How does that function? Well, if someone tells you we're trying to set out to change learning, worldwide, we want to change it all, I hope that the first question that comes to your mind is why. We all did learning probably in this classroom. In this room, probably the normal way, sort of the whole normal ascension through middle school and high school and college and maybe graduate school, etc. And we all turned out okay. So what's so broken with learning that we have to fix it? And I'm skirting over a lot of the depth of an answer to this question, but I will tell you one interesting thing that I found when I was thinking about this, which was that by the time you're 3 or 4, you learn what I call the fundamental principles, which are the extremely non-obvious things about how the world functions that you pretty much learn as a kid. You memorize them. You never stop to think about them twice for the rest of your life. But they're really completely non-obvious. And these are things like the sun comes up every morning and goes back down every night, and water is wet and fire is hot and sharp objects hurt. And if I jump up, I'll fall back down every time, et cetera, right? These are kind of arbitrary. I mean, you learn them as a kid. They're second nature. You really don't think about them. But so this is by the time you're 3 or 4. And you know, I contend that these are some of the sort of deepest and most profound type of things that you learn ever in your life. And just a year or 2 later, at 5 or 6, you go into school, and things just take a 180-degree turn. What do I mean by this? Well, look at how you learned all of those things by the time you were 3 or 4. I mean, you basically, you know, I don't know very many 3-year-olds that say, today I'm going to go and do some learning, right? Maybe, I mean, that'd be pretty cool, but I don't think 3-year-olds really do that. Instead, what happens pretty much without fail is they get constantly curious, right? I mean, these are kids at the age where there are more questions than there are seconds in the day. And because they get answers from, you know, parents and peers and friends, and because they sort of keep integrating those answers into their vision of how the world works constantly, every day, everywhere, that's how they learn. That's how they come to actually understand these sort of fundamental principles that I talk about. But here's what happens when you go into school. So there's essentially a flag day, right? You go into school, and literally at that instant, you're being told that the way you've been learning up to now, that's taught you everything you know, including these unbelievably deep and profound truths about how the world works, well, you know, we're going to throw that out the window and do something totally different. Why? Because we said so. And what's the different way? Well, you are certainly not really learning because of curiosity. You're learning because of authority. There's a teacher telling you to learn things. It happens for particular hours in the day in a particular place. And it's instead of being this sort of rapid exchange of, you know, question answer question answer question answer that's been critical up to this point. Instead, it's very unidirectional, right? There's a guy, there's a person sitting in front of the room, sort of imparting knowledge on you, and you're supposed to soak it up as a sponge. And here's the thing about this. If you grew up in most places in the Western world, you probably had at least once the experience of going through that process with a great teacher. If you have a great teacher, this is phenomenal, right? I mean, it's one of those rare, fantastic experiences where it just works. Now, thing about it is, if you have a lousy teacher, it's a pretty lousy experience. If you have no teacher at all, the system breaks down. It just doesn't work. If the way you teach kids, if the way kids are supposed to learn is by having that authority figure who is doing the unidirectional thing, and he isn't there, well then, you know, learning stops. And as it happens, outside of the Western world, it is incredibly frequent that there are no teachers whatsoever. In fact, schools in many places are a particular set of trees where, you know, kids will come and sit down. I mean, there are no classrooms, there are no school buildings, and very often there are no teachers. So why is this a problem? Well, because about 1/5, this is actually, there's about around, the estimates right now are about 1.2 billion kids in the developing world. That's 1/5 of the total population of the planet. So if most of that 1/5 of the global population of the planet doesn't have proper access to learning, we should be worried. And estimates go up to 75% of these kids having insufficient access to education or no access to education. So I think we can agree that what these kids actually lack is not ability, right? It's not a matter of not being able to learn. It's really a matter of not having the ability to learn. I'm sorry, not having the opportunity to learn, not being put in a place where they can somehow learn despite the failings of the system. And what do you do to fix this kind of situation? I mean, it's huge. I keep thinking, you know, myself about this number. I mean, 1.2 billion people, that's a lot of people. So how can you even attempt to address a problem at this scale? One solution is you could try and engage yourself in this massive top-down rethinking of everything that school is supposed to be. rethink all of education, rethink, come up with a global curriculum that everyone can agree on, train incredible amounts of new teachers, build incredible amounts of new schools, get all the schools and all the teachers trained in the new curriculum, get everyone doing this. If you're an unbelievable optimist, I think you could say that this can take 50 to 100 years. I'm a complete cynic and think this would never happen. But if you're really optimistic, say it's 100 years. Now remember where we were in 1907, and you'll probably realize that 100 years is a really long time, even if somehow magically at the end of those 100 years, things would really just get better all of a sudden, which, I think it's a pretty hard argument to make that they would. So here was a group of people that came to then found OLPC that said, there's got to be something we can do about this now. I mean, it can't be that we have to wait 100 years before we start seeing some kind of change. What can we do about it? And the next set of questions that were asked was, OK, well, if we, what would constitute the kind of sort of perfect solution to this? What would be the characteristics of such a solution, regardless of what the solution is? And there was an agreement on a set of characteristics, such as this peer learning thing was awesome when you were a kid. Can we leverage that again to bypass the problem of teachers not being there and schools not being there and get more learning again to be peer-to-peer between the kids themselves? The other huge thing that's important is you'd want to get the element of curiosity back in this picture. Curiosity is pretty universally what drove you to learn everything you know by the time you were 3 or 4. Let's get that back in the picture too. A kid should be able to get curious and get to answers that are behind the questions that he or she has. And what's probably more important is that kids should actually grow up knowing that when they get curious, they can get answers to the things they're curious about. So it was really only at this point in the whole thinking process that we said, laptops. We can do this with laptops. And we can attack the problem of education and learning with laptops. And then we can let sort of schooling, which is really a different concept than education, fix itself over time. So that's the educational segment. I usually do have quite a lot more to say about this. We can talk about it afterwards, so you can ask me questions afterwards if you want to elaborate on any of that. How do you build a laptop for kids? Well, I'll tell you immediately one way that you absolutely don't build a laptop for kids, which is take any of the laptops in this room and make it cheaper until it costs $100. Because what you'll have done if you do that is produced an inferior, outdated piece of technology that gulps an incredible amount of electricity, is underpowered, can't be used for most of the things that you guys can use your laptops. Any teenager in the West would be offended if you gave them such a laptop. It would break if you drop it on the ground. It wouldn't work in many of the places in the world that we're interested in that are either too hot or too rainy or too humid for normal laptops to operate. Really, you wouldn't have done much at all if that's all you did. So what do you actually do? How do you build a laptop for kids? Here is the X01 laptop, and Eben, my colleague, will do a short demo for you afterwards. But this is what the laptop looks like, and I'll open it up for you. So this is the machine. This is our pride and joy, and I'll pass one around in a bit. What's in here? Ultra low power little AMD Geode processor running at about 433 megahertz. And to put this into perspective, 433 megahertz is about one of the more powerful machines, most powerful machines you would have owned in 2000 if you were at sort of the front of the curve in the West. So at the height of the dot-com boom, certainly people didn't think that their laptops were, that their computers were useless and not powerful enough. And this is what they were using. So this is not nearly as antiquated as it sounds. So we actually did an upgrade. This is a more recent processor than we originally announced. It has a lot more cache on there, so things like Python run a lot faster. But I can talk about that a little bit later. There is 256 megs of RAM. There is a gigabyte of solid-state storage. So there's no hard drive in here. It's all flash, and there are no moving parts. And the solid-state storage has a limited number of write-array cycles, but they're wear-leveled. So the entirety of the flash actually gets utilized equally. When we say ultra-low power, we really mean ultra-low power. In many of the places where we're going, there just isn't electricity, period. At best, you can get electricity for certain hours of the day in the school, and maybe in one or two other places in the village. But in many villages, there just isn't electricity, period. And so we realized that with modern laptops drawing around 40 watts, there's just no way that you're going to be able to keep these powered and batteries recharged. And it's not enough to go from 40 to 20 watts. You really need to be going from 40 to a watt. So that's what we did. Our peak power consumption, this means if you're pegging our CPU and using all the peripherals that we have hooked up, the peak consumption is about 4 watts. So still an order of magnitude improvement over normal. If you're using the machine for standard activities, you're really looking at about 2 watts. And if you're using it in the ebook mode, or you're sort of using it as a book reader, you're looking at 1 watt or sub 1 watt power consumption. We're doing, to be able to do this, we're doing the sort of most ridiculously aggressive power management that I think has ever been done on a consumer device, period, outside Linux and outside everything else. Another thing I'm going to sort of skirt over, but I'm open to you asking me about it, is that essentially what we're doing is every few seconds that you're not actively utilizing your computer or the screen is not actively being changed, the computer will go into full suspend mode, except the screen, the image will still stay on the screen. And if you move the mouse or press a button, will wake up the entire laptop in about 100, 120 milliseconds. So much faster than you can notice that the laptop was ever suspended. And the way we did this, for those of you that are curious, is we basically ditched ACPI, which is a standard way of doing power management, and just re-rolled a completely different approach. The screen we have in here is quite a bit of a little marvel of engineering. It's something that we invented in-house, and it's a screen that is what we call dual mode, meaning that you can use it in a very high resolution monochrome mode. So resolution-wise, that's 1200 by 900. 200 dots per inch, which means that it looks pretty much like a printed book if you're looking at the screen. And you can then normally use it as a medium resolution color screen, like you'd be used to on a normal laptop. 692 by 520 in the medium color mode is roughly equal to 800 by 600 in terms of what you get. The neat thing about the screen is that it's sunlight readable with the backlight off. So here are 2 laptops. One is from a leading worldwide laptop manufacturer. And one is our cute one. And they're showing the same image on their screens. We are doing 802.11s mesh networking, which means we don't depend on there being access points in order to connect multiple laptops together. The user model, I mean, what you want for these kids is if 3 of them have a laptop and they go and sit under a tree somewhere, they should be able to open up their laptops and not even care about what networking or Wi-Fi or access points are. It should just work. They should create a network and they should be able to do things together. And to enable this, we're basically the first project anywhere to take an 802.11s draft, which is scheduled to be released as an official standard, hopefully in the reasonably short-term future. And we're implementing it on our machines in such a way that laptops can forward packets between each other and create networks without almost any user interaction. So that means that in addition to just not requiring an access point, laptops can actually forward packets along several hops. Meaning, if you have internet access at the school and you have a bunch of kids in the village that are not in range of there, but you have enough people sort of every 100 or 200 or 300 yards that they can sort of daisy chain packets all the way through, this will just work with, again, no configuration. We have a volunteer in the Australian outback who does network testing for us. He's not affiliated with us. We don't pay him. It's just something that he does to help. And he does constant range testing for us with a couple of laptops with his wife. And when the last numbers came in terms of how far the two laptops were while still maintaining a workable network connection, does someone have a guess as to how far apart they were? No guesses. Are you guys either shy or? 2 kilometers. Now, if that number came from me, you should be very skeptical. But no, it's about 2 kilometers, and we're actually upgrading to antennae that should give us even better reception. And one neat thing that I like as a hacker and an engineer is that we do diversity reception on the antennae, meaning that if you look at these cute 2 little bunny ears, which are actually antennae, antennae that, mind you, because they're raised away from the rest of the electronics, give you much more antenna gain than any of your antennae in your laptops. They do diversity reception, meaning that we can have one antenna hooked up to one network and the other antenna hooked up to another network, and we can actually be bridging packets between them if we want to. So here's what the mesh stuff looks like and how it works for those of you that are not familiar with the concept. So the idea is, OK, here's the school server, and here's a laptop that can't hear the school server, but here's a laptop that hears the school server. So if I'm here and I want to go to Google, I can basically say, I'm trying to go to Google, and find the route that ultimately reaches the school server through multiple hops, and then descends back to me that same way. In terms of standard goodies you'd expect, we have a bunch of USB ports. We have a pretty fast VGA camera. We have an SD card slot where you can throw in extra storage. We have a microphone. We have stereo speakers. We'll take power from anything that produces DC. It's actually 10 to 25 is an outdated spec. I think it's closer to 8 to 30 volts now in terms of what we'll take. So that means human power, outboard crank, outboard pedal, pull cord, solar, car battery, you name it, we can take power from it. Our touch. Was it $10 solar panel? I don't know if the pricing has been announced yet, but the solar panels are definitely being worked on. There's actually the really neat human power thing that we started up is something that we call the pull cord or the yo-yo charger. The idea is that you have a charger that really looks sort of like an oversized yo-yo that you grab and you can pull on it to generate power. You can take the charger and hang it off a tree somewhere or just off a wall. And it has, this is my favorite touch on the whole thing, it has a tiny little chip in there that will regulate the amount of resistance that the yo-yo gives based on how strongly you're pulling. So if you're a little kid, you can pull, and it's not very hard to pull, and you're generating some amount of power. And if you're a big strapping lad, and you grab it, and you start really pulling, it's going to be putting out quite a bit more resistance. You're still not going to be tiring too quickly, but you're going to be generating quite a bit more power. Our goal for that, by the way, is about 10 to 1, meaning you pull for a minute and you get about 10 minutes of laptop usage. We're toying with brand new battery chemistry that's not even on the market. It's looking reasonably likely that we'll be able to get this into the Generation 1 finished laptops. The nice thing about lithium ferrous phosphate battery chemistry is that it's less toxic, burns colder, is safer, and substantially lighter than the next best technology out there if you're looking for safety, which is nickel metal hydride. All of the laptops you have in the room are using variants of lithium ion or lithium polymer. The problem with that is, I'm sure you've seen the stories in the news. They are not quite renowned for being particularly safe or cold. So this is actually this is quite a big leap if we can pull it off in terms of how we're actually powering the machines. Normal audio stuff, all that you expect, except we hacked the microphone port so that you can actually read direct voltage from anything that you plug in there, meaning that for about $1 or 50 cents to $1, you can build little sensors for things like temperature or humidity or brightness and hook them up directly into the microphone port of your laptop and have a little portable science lab as you go. And this is all running on top of a Linux distribution that's based on Fedora very loosely. It's very stripped down, very slimmed down. But the packages, the binary bits are coming from Fedora. So, one thing that became, we knew from the beginning that we wanted to use open source software, but it grew over the life of OLPC to eventually become one of our 5 core, what we call 5 core values of the project, meaning that we originally said we want to do open source, but we're not zealous about open source. We're zealous about giving people freedom of choice. Meaning if you want to run not open source stuff on it, you should. And we're still sticking with that freedom of choice, but in our segment, in terms of what we're producing, we have decided to only use open source and free software. And we get a lot of questions as to why. Why try to commit to something like that? And the answer truly is because of the kids. Because if you're giving them this laptop and telling them that they should use this as sort of a window to the world, it's kind of a surrogate brain where every time you have a question and you don't have an answer, you should be able to pull out your laptop and go and look it up. If you're trying to champion a way to change learning that's critically based on the idea that you get curious about stuff and you go find out about it, then it doesn't really make sense to ship a box where if a kid gets curious about how the box works, they can't figure it out. It's sort of it'd be sort of a slap to our own face if we shipped essentially a black box that kids can't look into or change how it works. And so you build this as sort of a box of glass Legos, right? It's fun to play with at start, and you can be always sort of looking on the inside and figuring out what's in there. And then it gets really interesting because you let them take it apart if they want to, and put it back together in a different way and use what they came up with. This is tremendously powerful. Without this idea, open source, we wouldn't be here. We wouldn't be talking about this. This idea that you can take something, change it, put it back together, and make it better is, I think, what has to be the core thing that underlies all of the talks that have been here today, ranging from those about how do you make money with open source to us, which is how do you try and fix something that's broken with the world with open source. So we sort of took this to sort of a logical extreme where we said, well, right now, if you're just an end user, right? If all you want to do is do your word processing and listen to your music and watch your videos, as many users, even of open source, do. There's sort of this lie of open source, which is that it's open, which means anyone can go in and change stuff and make it better. But the thing is, the steps for getting the software and changing it and compiling it again, and it's a mess. I don't know who. So just so I have some idea, who here is technical enough that they, on some kind of frequent basis, will grab stuff off the web and hack on the code and recompile the code and so forth? Okay, so that's a relative minority in the room, and of the guys that didn't, of the people that didn't raise their hands, if I said, okay, Firefox, which probably everyone has heard of, would you feel comfortable if I asked you right now, without instructions, would you feel comfortable finding the source for Firefox, downloading it, changing something trivial like adding your name to the about box and recompiling and using that Firefox? Okay, so we have one person. Congratulations, you're a far braver man than I am. It's hard. It's hard. There's a lot of sort of making sausage that goes into open source software. You have to have the right build chain, the right tool chain, the right compiler, the right libraries, the right headers. It's complicated, and if you're trying to espouse this whole thing about openness and transparency and the ease with which kids should be able to get into this, it's not really enough to just say, well, if you get sufficiently curious to figure out compilers and tool chains and builds and all of this mess, then you can get to the source. So how do you make this really cool? How do you make this so that even the kids that are not the geeks will get curious enough at least to look at what's there? What if you could put a button on the keyboard that if you pressed, it would show you the source code of whatever you were running and let you change it right there. And if you hit save, it would reload your application on the spot for you without asking you any questions and show you the thing that you just changed. So that's what we did. And right there is a little yellow gear key that you can see on our keyboard. That is our view source key. If you press our view source key on a web page, you'll see the HTML. And if you press it while running a program, you'll see the code for the program opened up in an editor that'll let you make changes and save it. So
I have a question. Is that limited to only start Python program?
It's to start with, it certainly will be limited to mostly Python programs. Now, let me explain that in 2 seconds. There's nothing about this that makes it so that you can't support almost anything. Just because where our focuses lie and the deadlines we're on, we're going to do it primarily to start with Python programs. But certainly, it's open source. We'll take a patch from you if you want to support something else. Here's the next problem. There isn't that much drive space on this machine. There's a gigabyte of flash. And if you're really talking about massive recompiles and shipping the source for everything, which is large, the source to the recent version of the Linux kernel is something like 130 megabytes, right? You're not going to ship that on every machine. So how do you try to strike a happy balance? So you ask yourself, well, wow, I wish there was a program language where the source code was the executable, and where I could run something and it would be the same thing as compiling it, or I could open it up and have an interactive thing where I could edit and hack on things. And happens to be the case that there is just such a language. It's called Python. And it's the best thing since sliced bread, in my quite biased opinion. And we decided that almost everything that we can reasonably implement as Python will actually be implemented in Python on this machine. That really means almost everything. Our GUI, our window manager, all of our presence and communication stuff, even our init daemon that actually boots the system, the platform, the security platform, the crypto service, the file system, search, most of the user space code, we're not going to be rewriting huge chunks of working code in Python like x.org or our sign daemon or our system bus. That'd be sort of a exercise in pain. And there are already sort of bombs in there, like file system. You don't really think of file systems as being written in Python and running in user space and letting the user change how they work. But that's actually what we're doing. And the reason we're doing this is because our user documents, things like your music, your pictures, your things you wrote, messages you sent to people, live in a kind of centralized data store on the machine that is going to let you do all sorts of crazy things that previously was limited only to geeks who were getting it from version control software, or people running very expensive packages for team collaboration and so forth. So we can do everything from n-way synchronization between people to delta compression to tracking all sorts of metadata for everything that you put on there. We can do pervasive search, meaning the moment something lands on your machine, it's searchable. We can sort it, we can filter it, we can show you a timeline of how it works and what you've done at certain points. The GUI, and this is a different kind of sugar than the sugar you've heard about before me. Our GUI is called just sugar, not sugar serum, and it's something that you can play with right now. I think Eben will be doing a little demo after me, but it's a different approach on user interfaces, and The reason we felt this was necessary is because we wanted to add more context and make collaboration something that's built in. Does someone have a cogent theory on why it is that in 2007, OpenOffice.org and all of the commercial packages it's competing with still don't have a simple two-click way to do real-time collaboration on a document? Does someone have a good idea of why that is? There is actually an answer, so it's not rhetorical. Well, the format, not so much. I mean, you could do it between two instances of the same application. Yeah?
I think we've relearned how to not collaborate.
Well, I have a technical answer. I think that's actually a... What's that? I don't think so. So here's what I think has been holding this up. There has been no presence standard that has actually found mass adoption. Meaning, if I want to collaborate with Eben, I need to tell my computer who Eben is. And who Eben is can be, Eben Eliason on AOL Instant Messenger. It can be, Eben 105 on MSN Messenger, and Eben on Yahoo, and Eben on IRC. And I can keep listing off these presence networks that are all different, don't really interoperate. And, software developers aren't crazy. They're not going to support collaboration across 20 different presence services and always be fielding requests for more. So we said, fine, we'll build in presence directly into our operating system, which means that if you're a developer, you can write things that are collaborative trivially. In fact, you don't even have to care about presence because the operating system will take care of presence for you. So we're building this directly into the operating system, meaning that if you want to collaborate, I can find Eben on my sort of buddy list. I can just say launch write, which is our word processor, with Eben, and instantly we're doing real-time collaboration. I'm doing something that pains my heart, which is I'm not going to be talking about the security stuff at all, because it gets very technical very quickly, although I will answer questions if you have any about this. But the short version is we built something very, very new and very different called bitfrost that tries to deliver much more security than is currently present in the normal consumer world. No antivirus needed, no firewall needed, and no pop-ups constantly being presented to the user asking them to permit or deny certain actions. We're doing updates. This is something that's sort of still open to discussion, how it's actually going to be done. We're just beginning to figure out core updates. Updating individual apps is still up in the air. Before I finish, I want to tell you where we actually are on all of the sort of good things that you've heard. So Sugar, which is the GUI, works. There is still quite a bit of work remaining to be done before we implement our human interface guidelines fully. But it works now. It's usable. It has been in pilots in Brazil, Nigeria, and Uruguay. And so kids actually are using it day to day. So it's not vaporware. Our shared spaces, which are one step up from the ability to collaborate in real time, the ability to sort of have a team space with a bunch of your friends and put things in there. Beginning work on this, it's not in there yet. On the security side, we just actually 2 days ago merged this huge kernel patch that lets us do what we need to. We started on the user space work. In terms of the power management, which is incredibly difficult, I mean, think about it. Your laptop usually will take 10 to 15 seconds to suspend or resume. We want to be doing it at 100 milliseconds, which is quite literally at the edge of human perception. So we have it right now down to 233 milliseconds, and we want to go to less than half of that. Firmware stuff, still quite a bit of work to be done. The crypto integration that we're doing is scheduled for sometime in the next few weeks. There's a lot of general profiling and optimization to make all of this run as fast as possible on a processor that, while not dog slow, is certainly not what many of us expect from our processors today. We keep starting up on profiling and optimization, and we get sort of distracted by other things that pop up that require more immediate attention. In terms of what's happening with the servers, so that you can do backups and internet gateways and so forth, that just started now. still have some missing pieces of this picture. Luckily, most of it does not block our first release, but still, certainly quite a bit of work done there. My point here, the reason to tell you this is that we're, I don't think that anyone can argue we're not dealing with some absolutely fantastic technology on almost every front, but there really is quite a bit of work left to be done. And so to give you some idea of just how much open source has come into this picture, here is a simple one-slide overview of the majority of the OLPC stack, software stack on the machine. So Linux BIOS doing super low-level hardware initialization, passing the baton off to open firmware, which acts as the real BIOS and bootloader, which then boots Linux, which is the kernel, which then runs HAL, which is the hardware abstraction layer daemon, which then starts up x.org, which is the Windows system, which then runs dbus, which is the inter-process communication layer, which starts up GTK, which is the windowing toolkit, and hippocanvas, which is a canvas that sits on top of that and actually lets applications draw on the screen. Network manager, which figures out network connectivity and actually connects you. Telepathy, which is a set of services that will let you do presence and make connections through NATs and so forth. Jabber and XMPP, which are the basis of all of these communication protocols, so completely open, completely open standards. Mozilla ZulRunner as the web browser. Python as the mother glue on this machine. AbiWord, the word processor that we adapted. SQLite for a lot of the storage. This is a lot of software. And in fact, it's thousands of man-years of work that were given to us so that we can basically pick and choose and put them together any way we wanted and contribute a lot to it, and then wind up with something that we want to give to these kids. And after I showed you that slide, I really think it should be clear that if you're trying to essentially reinvent the laptop, which is what we've been forced to do, trying to do this without open source, I personally can't fathom what it would look like. Even whatever resources you had available, I just can't imagine the kind and scale of development effort it would take to actually build something like this. So here's what this boils down to. We at OLPC think that if we succeed, there will be something unprecedented in the course of human history happening, which is that there will be a generation of kids globally where many or most of them will, for the first time, have access to knowledge and to learning and to education. And this is an incredibly dangerous and an incredibly powerful and an incredibly compelling idea. So I get asked a lot what it's like to actually work at OLPC, and people actually often ask me how many hundreds of programmers we have, and then I tell them that the core team was about 12 people, and then they don't believe me and ask how many programmers we have locked up in the basement. And the one thing I've started telling people, I love this quote from Edison, who said, hell, there are no rules. We're just trying to accomplish something. It's a perfect summary of what OLPC is doing and how it's actually operating. And the reason I'm telling you any of this is because I'm hoping that this struck a note somewhere in all of you, and that you'll walk up to me and ask how you can help. If you're a programmer, we have a LiveCD available that has Sugar and all the tools, and in fact, Doug has, I know, a number of LiveCDs with him. So they're in the back of the room. There's an OLPC label right there. You can pick one of those up. We have actual real laptops available that we will give you free of charge if you're interested in doing some of the sort of low-level work that really requires the laptop, or any of the higher-level work that requires seeing what things look like on our screen, which is different than what you have. There are about, I think at this point, about 2,500 of these laptops in the hands of developers all over the world. All of the code that we write and that we use is completely open source and free software. It's available on this site along with our bug tracker. We do something interesting which is we don't have a private or secret bug tracker. Every bug that we know of is meticulously kept track of in our completely public bug tracker. And it's another world first, I think, that you can see if you go through our bug tracker historically and basically look at the timeline of bugs flowing in and bugs getting closed. You can see what it actually looks like to develop a laptop from scratch. Literally from the moment that we had no laptop, we had motherboards that were coming in and had a bunch of bugs, both in hardware and in software, and those bugs were getting registered and then fixed, to every iteration of the laptops that we're getting up to now beta 3, and with beta 4 scheduled to come out pretty soon. So it's quite a fascinating thing to watch. That's all I have prepared for you. Eben has a very short slide deck on the UI stuff, so I'll call him up in a second, but I will take any questions for me before Eben does that, and you're certainly welcome to wait until he does that and then ask me questions again. So thank you. Yes?
Do we want to move to Eben quick, or
why don't...
it's quarter after?
OK, sure, let's do that.
While Lily's coming up.
Thank you for the presentation. You talked a lot about technology. What about the users? What are the kids saying about this? How are you measuring the user experience and making sure that what you want to achieve is what you're planning to? I see that that's a very sophisticated machine, what you're creating there. Aren't you thinking that maybe it's over the top on technology for kids that maybe want to access just a few features? It's like having this very sophisticated mobile phones where you only use it for calling. So what are your views on that?
Do you still have the username and password? Can someone grab the sheet with the username and password? I want to show you something. Doug, can you grab the sheet that has the username and password? Sure. While Doug grabs this, here's the thing. It takes a whole lot of complexity for the user experience to be simple. In fact, if we weren't trying to have a user experience that is beautifully simple, I think a lot of the stuff that we're doing we wouldn't have to be doing. So Sugar, which is the UI that we're building, is built with the idea of simplicity and of a fantastic user experience. As soon as someone logs me in, I want to show you a page that's about, I think, 3 or 4 days old that has more than just what I can tell you. Yes, in the back.
I think a better answer to that is that we confuse. Sort of, there's a condescending view. You've got to make it simple so kids, everybody can use it. When this is really to create as much opportunity for discovery as possible. So it has to basically give as much openness for learning as it's not a solution to a problem. It's the start of a learning process. So there has to be as much potential as possible.
So one thing that we talk a lot about in the OLPC headquarters is the idea of the onion metaphor, right? Layers to peel off. There is a way to make it start simple, and then as the user matures and as the kids want more out of their machines and want to figure out more stuff that their machine does, they can basically start progressing as the user and revealing sort of more complexity and more details. And I very firmly believe that that's actually the way that every system should be designed, including all of those that we're using and that just completely aren't designed that way. But if you go to wiki.laptop.org, by the way, which is our wiki and is kept up to date, reasonably up to date, and has a very active community, if you look at the What's New section on the front page, there is a report from a school in Galadima, Nigeria, that just came in a few days ago. And here are some of the kids. If you're just looking at the pictures, really, if you go and look up one thing after my presentation, please go check out this report. I can talk at you all day, and in the end, you go and you read a report that was actually written down from the field, and you look at what these kids are doing with these machines, and I have no reason to lie, my jaw dropped. When I read this report, I really had a wow, this is real moment. So, yeah. Yeah, let's do that.
It'll be a little different once you see the user interface.
You have a mic?
Here, let me get you.
This is fine. I can use this.
I turned it up. Okay. Use that.
Okay, so Eben Eliason is one of our core UI and user experience designers at OLPC. And
in fact, the only. I work with a team of, well, a pair of designers at Pentagram Design Firm in New York as well, who have been helping out on the project. But as he mentioned, it's a small core group, and we're trying to do a lot. There's a lot to be said about our user interface. It's not like anything you've really seen before. And that stems from two core principles that he talked about, which are collaboration and exploration. In my mind, those are really the two things we want to highlight as much as possible at the very core of the interface itself. And so to figure out how to do that, how do you make seamless integration with collaborative apps, as he was talking about earlier, work from the UI itself? We came up with this idea that we're going to make a Zoom interface. And well, let me back up one step. We've got this little XO character, and he is going to be the representation of each of these kids in the network space. And each kid gets to choose a pair of colors, since kids love customization. And that set of colors will, in a way, carry on their identity, again, throughout the network. And stepping back one level from the home screen, where it's just about you, we see there's friends. And beyond that, there's the neighborhood. And all of these levels that I'm talking about, as he mentioned, are just within the mesh. This isn't requiring any kind of internet connection at all. It's just completely exposed by the GUI itself. And finally, there's a fourth level called the activity level. And let me show you how joining an activity might work in the mesh. Here's the home screen. If we step back, here are my friends, and you can see underneath what each of them are doing. And back one level further, we see the mesh. And so here you can see there are a bunch of these little XOs. They're clustered around the activities that they're currently participating in. There are some printers, some wireless access points. Everything that's around in the network can be seen right here. And by exploring a little bit, I can find out what's going on. And I can easily just join that activity. And actually, this slide is kind of important. We have some new jargon, I guess, around the office. And you could say it's all semantics. But really, we think there's something a little bit bigger going on here. We're really trying to emphasize the idea that you interact with the software and with all of the other people who are using the software with you. It's all about activities and about exploring, not so much just about this thing that's running on this machine that I have in front of me. That's the technology standpoint, but this is all about doing. So I apologize, a couple of these slides are kind of blurry. I pulled them off the wiki this morning. They're all up on the wiki, actually. If you go to wiki.laptop.org/go/activities. That's the starting point for all of the things that I'm going to show you. So this is the browser. It doesn't quite look like this on the XO yet, but I'm just trying to show you where we're heading with everything in the interface. And you can see it's fairly straightforward. There's forward, back, refresh, all the things that you'd expect. Down at the bottom, though, there's something a little bit different. There's this tray. There we go. And inside that tray, you see these little icons. And also up at the upper right, you can see that there's matching icons there. The idea here is that we want to emphasize collaboration even in a browsing setting, which no one's really thought of doing before. The closest that we've come, really, is through things like Delicious, social networking types of sites, where you can post links for your friends, but it's all time-shifted for the most part. And so here we want to embody the idea that a whole bunch of people can come together, browse the internet together, and share things with each other live. So as you make bookmarks and you make shared links, these little icons show up at the bottom of the screen, And that's shared among everybody else who's currently participating in the activity. So I can see, this little orange one might be Ivan right here. And so I can take a look at what he thought was interesting at the moment. And another quick comment about the way these activities are working on the laptop is that everything is session-based at the core. They're all full window. And we've got a journal, which is the file system that he mentioned, that is going to keep track of all the things that you do, the activities, not so much the objects, but the things that you're actually working on. And so if I come into this web browser, I can make a couple tabs, I can browse around, I can make some shared links, and when I go home at the end of the day, I can open that session back up with all of the tabs and all of the links still within it. And if I jump ahead here, I'll bypass that one. I'll jump to this one, because this one's actually pretty important. These kids are going to be in places where there isn't always internet access. In fact, many of them will only have internet access at the school. And when they're at home, obviously, in an optimal environment, they'll have a couple hops to the school server anyway and still be able to get out. But when they can't, they could have loaded up a few pages while they were at school that their teacher wanted them to look at, come home, open up the browser again, and then use fully cached pages without fear of accidentally hitting refresh like I do all the time on my laptop and lose the directions or something to where I was going. So, and of course, it'll tell them that this isn't a live version of the page, but it'll let them continue to read and explore at home as well as at school. So I'm just going to run through a couple quick activities here. This is the write activity. It's a simple word processor. You can also see at the top of the screen, we have what we're calling the toolbox, which consists of several trays of tools. And in almost all cases, there's usually a primary core set of tools in the first tray. And so that's the text editing tools. And if that's all a kid wants to do is type a little bit, they can. But if they want to explore some more, they can open up the image tray or the table tray and start importing images, making tables, changing formats, doing all these kinds of things. And all of this, of course, is interactive, which is why these colors are showing up on the screen. That represents the text that each kid is writing. And the other important thing, I guess, to note about the toolbox is that it's completely context sensitive. So if I click in a text region, the text tool, the text tray will automatically select itself. If I click on an image, the image tray will select itself. So we're really trying to expose things as necessary, but not overload the interface with a whole bunch of tools at once, especially because it's also such a small screen despite the high resolution. Here's an example of the table toolbar. Here's the drawing activity. Again, your basic drawing tools, but there are a lot more available if you explore a little bit. And here's a little example of how there's even more exploration to be had with each tool individually. This is the shapes toolbar. And there's some basic shapes. You can just kind of drag and draw whatever you want. But if you bury down a little more, you'll find more information about the tool and parameters for the tool, which adjust how it functions. And that idea, this rollover, is going to be a standard throughout every single interface that's built for the laptops. Here's a quick example of a fun little app. This is the video chat app. It's pretty simple. I don't need to say much about it. But you can draw on it and around it. You could teach each other math or just have some fun or play a game on the side. You can take a photo and store it into your journal so that you have a record of what you've done. Here's the read activity. Again, simple. We've got the idea of bookmarks, and hopefully down the road we're going to add some pretty extensive annotation features as well so that kids can talk about things and share things and pass them around. And this is also just a little prototype idea, but down here at the right you see these little dots. This is a proposal for an idea that each kid who's currently in the activity could be represented over there, so they could actually kind of follow the teacher's dot around the document if they're exploring. Here's the record/capture/photograph activity. It's going to have a few different features. It's going to have time-lapse, photography, audio, and video, and still image. And you can tag images. And down here, this is basically a roll of film. And each photograph there is identified by its color. If you roll over each one, it'll tell you exactly who made that photo. Yes? Oh, taking too long. Sorry. OK, so here's a calculator, memorize, tam. There's a whole bunch of activities being worked on. I'll breeze through the journal really quickly. This isn't even the latest design for it. But basically, it lets you search, filter, sort anything you want. It's got a powerful sort by, then by type functionality, which gives you some basic hierarchy, even though it's at its core a linear list of all the things that you've done. And I guess that's it. So we can open it back up for any more questions. Oh, sure. We're going over there for the camera. Is this mine? No, the laptop is over.
What I'm going to do is I'm going to set up here so that we can actually see it in operation. The one that you have. You want to bring the hands down?
Someone has it. Excellent. OK, in the meantime, I'll take some questions.
How many kids on the UI team?
Not very many full-time, lots in iterations. So a lot of this is getting thrown in front of kids, and we're looking at how they're dealing with it.
Okay. Hold on a second.
Yeah.
Can you give an example of programming capability?
Repeat the question. Repeat the
Well,
question.
nice to see programming capabilities exposed to the kids.
Yeah. So there's one of the activities that we're building is called the develop activity, and it's essentially a very simple-to-use IDE that lets you, when you press the view source button, basically loads up the source code for that, and you can do some basic development right in there. And that'll have all the sort of collaboration features that we're trying to build into the rest of the machine. So Python is our core platform language. It's the only, well, so OK, in terms of the languages that we ship on the machine, there's a Python interpreter. There's clearly JavaScript in the browser. There's Squeak, which is a self-contained dialect of Smalltalk. Evan, did I miss any?
Sorry, I wasn't paying
Python,
attention.
JavaScript, Squeak. Oh, we are looking at a variant of Logo as well.
Move away from the
Let me move away from the
Why
screen.
don't you sit over here with
Sure.
him right behind. I'll turn this way. Okay.
Okay.
And actually, do you want to run the camera so you can show what you think is of interest?
I think it's
Zoom in. Like that?
Sure.
Do you want to explain what you're doing?
OK, so I'm just going to give a really quick overview of what I just showed you actually running live on the laptop. So this is the home screen. And around the edge of the screen is what we call the frame. And
That's good.
OK. And the frame is carried with you across all the various zoom levels. And there's not much in it at the moment. There's no one else around. Otherwise, I'd see some people over here. And I haven't done any copying or pasting. Otherwise, I'd see objects stored in the clipboard over on the left. Up here, I can use the buttons to navigate around. So this is the groups view. Of course, again, there's no one else around at the moment. And zooming all the way out, I can see the mesh, and here's me. And here are some of the wireless access points around. I assure you that this is a much more interesting experience when there's another 20 or 30 XOs nearby. And so I'll just dive into the web browser here for a second. And let's see, we'll just pull up Google Maps as a demo. Or
Are you connected still?
I was connected. Perhaps not.
It'll take a second to associate.
Yeah, I know. I'm going to need the password again.
Yeah, that's a problem with this location. Every time you power down.
Oh, yeah.
Sorry.
Lean back a little bit. This is the same problem we're having with regular PCs.
As I test my typing skills on this tiny little keyboard. Oh, come on.
Okay, well, we have to take our word for it that this actually works.
Why don't you show the camera app and the sound app and the music
Okay.
app?
There we go. So here's the camera. You can see here's a little photo I took of myself earlier at the bottom. And there's a new one. As you can see, again, this interface is not quite what I showed you in the mock-ups, but everything is in flux, and builds are changing from day to day.
Show how fast the video is going again. So this thing can actually run real full-time, full-speed video.
I can't because there's a bug. Hang on.
We actually did a transatlantic Cambridge, UK to Cambridge, US video conference call, and that ran at 15 frames per second on our old hardware with full sound. So it should we should be able to get about 30 frames per second full rate with the new hardware.
Pretty fast. And also pretty clear. This was sort of an old build for which we couldn't actually scale the video that was coming in. But at full screen, it's still pretty high quality.
Want to run the sound app?
Sure.
Make some music? See why kids will be interested.
So this is Tam Tam. I guess I'll show you the mini version. This is the version kids will jump into, and it's also going to be the first to have extensive collaboration capabilities. And once again, the interface will look a bit more sophisticated. But let's start at, well, here's a piano.
Okay, so what, instead of
closer there.
Can you
Is it
hear
picking
that?
up at all?
Okay, well, I'll tell you what. Why don't we actually wind up, sort of wrap up the look at it on the screen. If you want to see the laptop, you can come up and you can actually see it play some music.
I can give a little
But,
demo of it. Oh, you can hear
yeah.
that.
Okay, there you go. Birds. So anyway, thank you for having us. If you want to see the laptop, coming up.
No.
I think we.
Okay, thanks everybody for coming. We really appreciate it. And don't forget your blue sheets, please. And then a big round of applause for Dan Bricklin for all the video and audio running around. Thanks, Dan. Appreciate it.
Thank you.
Thanks, guys, for coming.
Absolutely.
Appreciate
It's a pleasure.
It's a terrific talk, too. Thanks. Great demo, too.
Thank you.
So the mouse is
And actually, these sections are resistant, so if you have a stick or something or a fingernail.
Okay.
All right. Thank you. Soon. Take a look at our office. Back up a little bit.